morning sun cast long shadows across the Gulf of Mexico as crews aboard the Deepwater Horizon prepared for what they believed would be another routine day. The massive drilling rig towered 11 stories above the water, its derrick reaching toward the sky like a steel monument to human ambition. For the 126 souls on board, April 20th would begin like countless others before it, with the steady hum of machinery and the familiar rhythm of offshore life. But beneath the surface, nearly a mile down in the crushing darkness of the ocean floor, a series of events had already begun to unfold that would forever change the lives of everyone aboard. What started as a straightforward drilling operation would become one of the most catastrophic industrial disasters in modern history. This is the story of the Deepwater Horizon. The Deepwater Horizon was no ordinary drilling platform. Built in South Korea and commissioned in 2001, she was a semi-submersible drilling rig capable of operating in water depths exceeding 8,000 feet. At 396 feet long and 256 feet wide, the rig was essentially a floating city equipped with everything needed to sustain life and work in the middle of the ocean for months at a time. Her crew quarters, galley, and recreation facilities provided comfort far from shore, while her advanced drilling systems could penetrate miles into the Earth's crust with remarkable precision. Owned by Transocean and leased to British Petroleum, the Deepwater Horizon had been working the Macondo well site since January. Located approximately 40 miles southeast of the Louisiana coast, the well represented one of BP's most ambitious deepwater projects. The target reservoir lay buried beneath 13,000 feet of water and sediment, holding the promise of millions of barrels of oil. By April 20th, the drilling phase was nearly complete. After months of careful progress, the well had reached its target depth of over 18,000 feet below sea level. The crew was preparing to install the final production casing, and cement the well in preparation for future extraction was dangerous operations. It worked in an unforgiving environment, but these men and women were among the most experienced offshore workers in the industry. The rig operated under a web complex of responsibility. While Transocean owned and operated the drilling equipment, BP maintained overall control of the well design and drilling program. Halliburton provided cementing services, while other contractors handled various specialized tasks. This intricate arrangement required constant communication and coordination between multiple companies, each with their own procedures and priorities. As dawn broke on April 20th, the morning safety meeting convened as usual in the rig's conference room. Crew members discussed the day's planned activities, reviewed safety protocols, and addressed any concerns about the ongoing operations. The atmosphere was professional and focused, with veteran hands sharing their expertise with newer crew members. Many of these workers had spent decades in the oil industry, following opportunities from the North Sea to West Africa to the Gulf of Mexico. The well itself presented unique challenges. The high temperature and pressure environment at such depths created extreme conditions that pushed equipment and procedures to their limits. The Macondo reservoir contained oil and gas under immense pressure, requiring careful management of well control systems to prevent uncontrolled releases. Multiple barriers, including heavy drilling mud, blowout preventers, and casing systems were designed to contain these forces and ensure safe operations. Recent days had seen some complications with the cementing operations. The well's geology proved more complex than initially anticipated, with variations in pressure and rock formations requiring adjustments to the drilling plan. Engineers on shore worked closely with rig personnel to address these challenges, modifying procedures and equipment as needed to maintain safe and effective operations. The morning shift took over from the night crew with the usual handover briefing. Key personnel reviewed well conditions, equipment status, and planned activities for the coming hours. The drilling mud system maintained proper pressure control. The blowout preventer stew seal, lead ready to safety systems show well if needed, and ALD green across the board. Everything appeared normal as the crew prepared to continue their work. Meanwhile, BP, IN's offices hundreds of miles away, engineers monitored the well's progress through real-time data transmitted from the rig. Pressure readings, mud flow rates, and other critical parameters streamed continuously to shore, allowing specialists to track conditions and provide guidance to the rig crew. This technology represented one of the industry's greatest advances, enabling complex deepwater operations through constant communication between rig and shore. The Macondo well had already cost BP over $100 million and taken longer than expected to complete. Pressure to finish the project and move the expensive drilling rig to its next assignment weighed on everyone involved. In the offshore industry, time literally equals money, with daily rig rates reaching hundreds of thousands of dollars. Balancing efficiency with safety required constant vigilance and clear communication between all parties. As the morning progressed, preparations continued for the critical cementing operation that would seal the well's production zone. This process involved pumping specially formulated cement down through the drill pipe and up around the outside of the casing to create a permanent barrier. The cement job had to be perfect, as any flaws could allow oil and gas to migrate up the wellbore, potentially creating dangerous conditions. The crew had performed similar operations countless times before, but each well presented its own unique characteristics. The Macondo well's high-pressure and temperature environment required careful attention to cement formulation and placement procedures. Halliburton's cementing specialists worked closely with BP engineers to design the optimal approach for these challenging conditions. By late morning, final preparations were underway for what everyone expected would be a routine cementing operation. Equipment checks confirmed all systems were operating normally, mud pumps maintained proper circulation, and the blowout preventer remained on standby. The crew moved through their established procedures with the confidence that comes from years of experience and rigorous training. But deep below in the reservoir, pressures that had been contained for millions of years were about to test every barrier, every procedure, and every assumption that had brought them to this moment. What happened next would transform an ordinary day into a nightmare that would haunt the Gulf Coast for years to come. The cementing operation began at 1:30 that afternoon, with Halliburton's crew taking the lead. The process required precise timing and coordination, as thousands of barrels of specially mixed cement were pumped down through the drill string. This cement would form the crucial barrier between the high-pressure reservoir and the wellbore, essentially plugging the well until production operations could begin months later. Jesse Galliano, Halliburton's cementing engineer, monitored the operation from his station aboard the rig. The cement mixture had been formulated to withstand the extreme downhole conditions, but questions lingered about its effectiveness. Earlier tests had shown some concerning results, yet the decision was made to proceed with the operation. Time pressures and operational costs weighed heavily on everyone involved. As the cement flowed down the wellbore, circulation rates and pressures appeared normal. The crew carefully tracked the cement's progress, watching for any signs that might indicate problems with the placement. Everything seemed to be proceeding according to plan, but deep in the well, the cement was not bonding properly with the wellbore walls. Small channels began forming, creating pathways for oil and gas to migrate upward. By 5 p.m., the cementing operation was declared complete. The crew began the process of displacing the heavy drilling mud with lighter seawater, a standard procedure that would reduce pressure on the well and prepare it for temporary abandonment. This displacement operation required careful monitoring, as reducing the mud weight would decrease the pressure holding back the reservoir fluids. Jimmy Harrell, the senior tool pusher and one of the most experienced hands on the rig, oversaw the evening operations. With over 3 decades in the oil field, Harrell had seen every kind of well condition imaginable. But as the mud displacement continued, subtle signs began emerging that something might be wrong. Pressure readings fluctuated slightly, and the mud returns didn't quite match expectations. The evening shift took over as darkness settled across the Gulf. The rig's lights illuminated the work area as crews continued the displacement operation. In the drill shack, mud engineers monitored their gauges while roughnecks worked on the drill floor above. The familiar sounds of offshore drilling filled the night air, but experienced ears began detecting subtle changes in the usual rhythm. At 8 p.m., the crew conducted a positive pressure test to verify well integrity. This test involved pressuring up the well and monitoring for any pressure drops that might indicate leaks in the casing or cement. The initial results appeared satisfactory, giving the crew confidence that the well was properly sealed. However, the test conditions didn't fully replicate the extreme pressures that would be encountered once the heavy mud was completely displaced. As the night progressed, the mud displacement continued. Thousands of barrels of drilling mud were pumped out of the well and replaced with seawater. Each barrel displaced reduced the pressure holding back the reservoir, bringing the well closer to a critical threshold. The crew monitored returns carefully, but the complex flow patterns in the wellbore made it difficult to detect early warning signs. Donald Vidrine, BP's company man aboard the rig, maintained communication with shore-based engineers throughout the evening. The pressure to complete the well abandonment procedures and release the expensive drilling rig for its next assignment remained constant. Every day of delay cost hundreds of thousands of dollars, creating an environment where efficiency often competed with caution. By 9 p.m., unusual pressure readings began appearing on the monitoring equipment. Some crew members noticed discrepancies between different pressure gauges, but the readings were initially mentation problems dismissed as instru. The complexity of deepwater well control systems made it challenging to distinguish between equipment malfunctions and actual well conditions. In the engine room far below the drill floor, the rig's massive generators hummed steadily, providing power to the drilling systems. The mud pumps continued their rhythmic operation, maintaining circulation while the displacement proceeded. Few aboard realized that with each passing hour, the balance between human engineering and natural forces was shifting toward a tipping point. The mudroom, where drilling fluid properties were monitored and adjusted, became a focal point of activity. Mud engineers tracked the displacement progress while analyzing returning fluids for any signs of contamination. Small amounts of gas began appearing in the mud returns, but these levels initially fell within acceptable ranges for the operation. As the evening wore on, pressure anomalies became more pronounced. The well began showing signs of flow when circulation stopped, indicating that reservoir fluids might be entering the wellbore. These kicks, as they're known in the industry, required immediate attention and careful well control procedures to prevent escalation. At 9:30 p.m., the crew attempted a negative pressure test to further verify well integrity. This test involved reducing pressure on the well and monitoring for any flow that might indicate communication between the reservoir and the wellbore. The results were ambiguous, with different interpretations possible depending on which monitoring points were emphasized. The decision was made to continue with the displacement operation despite some concerning indicators. The well had passed earlier tests, and the pressure anomalies were attributed to operational complexities rather than fundamental problems with well control. This decision would prove fateful, as conditions deep in the wellbore continued to deteriorate. By 10 p.m., the final stages of mud displacement were underway. The heavy drilling mud that had provided the primary barrier against reservoir pressure was being systematically replaced with much lighter seawater. Each barrel of mud removed reduced the well's ability to contain the immense pressures below, while the compromised cement job provided an inadequate secondary barrier. In the moments that followed, the delicate balance that had kept one of nature's most powerful forces in check began to fail catastrophically. The events that unfolded on the Deepwater Horizon that night would claim 11 lives and trigger the largest marine oil spill in history. For 87 days, millions of barrels of oil poured into the Gulf of Mexico, devastating coastlines and communities that depended on these waters for their livelihood. The disaster exposed critical flaws in deepwater drilling practices and forever changed how the industry approaches offshore operations. Today, the Gulf continues its slow recovery, while the families of those lost carry memories that time cannot heal.